Hi everyone, this is Ashwin from Robojunkies, and in this video we will take a look at how to program the LF2 line follower kit. This is a follow-up video to our assembly guide on the same kit. A line following robot essentially does three things. It senses the line, converts this data into speed for each motor, and sends the appropriate power to each motor. This can be achieved using various types of robots, programs, and techniques. What we look at today is more specific to the LF2 kit. As seen in the previous video on this channel, the LF2 kit is based on the Arduino Nano TB6612FNG motor driver and a 5-channel analog line sensor. So the discussion today will be relevant to these parts. The Toshiba TB6612FNG chip is a very versatile motor driver commonly used in small size robots. It can provide 1.2 amp current per channel, which is sufficient for the motors that we are using. To know more about the chip and the associated Arduino library, please refer to the brilliant tutorial on SparkFun's website. Link is in the description. First, we'll need to install the library to be able to control the motors. The SparkFun website has the link for this library. Once the library installation is done, we will test whether the motor connections are proper and if they are moving in the right direction. The sample code we will be using looks something like this. This code will make the robot move forward for 1 second, then stop for 2 seconds. In case your robot starts turning in this step, check which motor is going backward and interchange the connections of that particular motor. Now that the motor connections are proper, let's take a look at the sensor array. We have used a 5-channel sensor array which gives us analog values for each sensor output. To test out the sensors, we can use a simple sketch which reads out the values for each sensor using the analog read command. The values of each sensor are printed out on the serial monitor. Note that these values will vary according to different surfaces, colors, lighting conditions, etc. To get the best results, I generally use a design which is printed on a material called Starflex. The line is a 2 cm wide black line which is printed on a white background. Although this code should also work for line thicknesses of 1.5 to 3 cm with some minor modifications. Now let's take a look at the actual code for the LF2 robot. At the beginning, we have to set the pin declarations for the motor driver. These connections are pre-made on the carrier board and will not change. Next comes the initialization code for the motor driver so that we can use the library functions in the TB6612FNG library that we earlier installed. The next part of the code are declarations for the variables that we will be using in the program. In the setup code, we will need to declare the pins 11 and 12 as input pull-up so that we can use the buttons on the carrier board. Now let's take a look at the loop. The program starts with the Arduino waiting for the button 11 to be pressed. Once you press this button, there is a small delay and then the robot starts the calibrate routine. The calibrate routine is used to read the mat and let the robot understand what is the actual reading for black and white. In the calibrate code, there is a loop that runs 3000 times which checks each sensor and records the highest and lowest values. The highest values correspond to the black line and the lowest values correspond to the white background. Once the robot knows these values for each sensor, it calculates a threshold value which is the midpoint between black and white values. All of this is done while the robot moves in a circle, so it kind of scans the area underneath. Once the sensor calibration is done, the code waits for the user to press button 12. This triggers the actual line following part of the code which is inside a while loop. Now let's move on to the line following code. The code is divided into 3 parts: extreme left turns, extreme right turns, and line follow using PID. In case sensor 1 sees black and sensor 5 sees white, the robot takes an extreme left turn by turning the left motor off and running the right motor at 200 speed. In case sensor 5 sees black and sensor 1 sees white, the robot takes the opposite turn. In the last else if block, the robot actually follows the line using a PID routine if sensor 3 is seeing black. It is in the line follow block that we actually see the PID control being used. The error is calculated using sensor 2 and sensor 4 since they are in the best position to monitor small changes in the line. After generating the P, I and D components, the PID value is calculated and an appropriate speed is passed to each motor. If the line shifts a bit to one side, one motor goes marginally faster and the other one goes marginally slower to get the robot back on the line. The speeds are limited to a value between 0 and 255 since these are the maximum permissible values for a PWM signal. Once you press the button 12, the robot should start following the line. Here are some troubleshooting tips in case you find some trouble running the robot. If the robot wobbles too much, first check if the wheels and track surface are clean. If the problem persists, try reducing the KP value here by reducing this multiplier value. Ensure the sensors are attached properly and they are sensing the mat from a height of 5 to 8 mm. This is why you are provided with some spacers to ensure the right distance. Make sure the battery you use is not very heavy since weight distribution is one of the most important aspects of a line follow robot. So what we discussed here is just one way to code a line following robot, and I would encourage all of you to try tweaking the program to figure out how fast you can go through your track. If you have made a faster robot, please let us know by commenting here. In case you'd like us to cover some other aspects of line following, do let us know. And thank you for watching and have a great time tinkering.